So I'm going to go through and explain the kinetics of crystal violet fading lab that we completed. All right. So the first thing that we did in this lab was we created our different standard solutions. Okay, so these are solutions of crystal violet whose concentration we know. And the reason why we created these standard solutions is we needed to create a Beer's law curve. And so the way that we did that was we actually took each of these solutions of known concentration, we put them in the spectrophotometer after first setting the spectrophotometer to a specific wavelength that we had determined previously. Okay? And remember that wavelength we determined we want it as high of an absorbance as possible, but it must be below 1.0. All right, so we determined the absorbance of each of these different concentrated stock solutions, and we created a Beer's law curve. Okay, so if you look at this graph, unfortunately, the x and the y-axis aren't labeled, but the y-axis here would be absorbance and the x-axis would be concentration. So we create a Beer's law curve. And the reason why is we need to be able to relate absorbance and concentration. So here, if you notice, you've got this linear equation here. Y represents the absorbance and X represents your concentration. Okay, and I'll go back to why we needed that in just 1 second. So we've created our Beer's law curve, which is the first part of this lab. Now we are going to combine crystal violet and hydroxide, and we allowed it to react. Okay? What happens to crystal violet as it reacts with hydroxide is the dark purple color actually becomes lighter in color. And so that enables us, because it's colorful, that enables us to determine both the absorbance and therefore the concentration of the solution as the reaction proceeds. So then, as soon as we put the crystal violet and the hydroxide, as soon as we mix them together and allow them to react, we put that cuvette into the spectrophotometer. And the reason why we had to do that immediately was we wanted to start measuring the change in concentration at the very beginning of the reaction. Okay? Then we measured the absorbance every 20 seconds, okay? And we recorded the absorbance on a data table. Now, the reason why we need the Beer's law curve was we could then take those absorbances and convert them into concentrations by using your Beer's law curve, okay? And once we had all of the concentrations, what we did was we created 3 different graphs. We graphed concentration versus time, the natural log of concentration versus time, and 1 over the concentration versus time, okay? And what we found was that when we plotted the natural log of concentration of crystal violet versus time, we got a negative linear graph, which tells us that the reaction of crystal violet with hydroxide, the reaction is first order for crystal violet. Just a couple of notes about this laboratory procedure, because we can always change the actual details of the procedure, but the major points that need to be noted. First of all, remember if the graph of 1 over concentration versus time is a positive linear slope, then you know you have a second order reaction. A couple of other things, remember if one of the most important things for this lab was making sure that you didn't get fingerprints onto the cuvette. So if you get fingerprints onto the cuvette, remember that the absorbances you would measure would be higher than they should be because the grease from your fingers will absorb some of the light. Also keep in mind that if you significantly delayed putting the cuvette with the reacting crystal violet and hydroxide into the spectrophotometer, remember as the reaction proceeds, because you're reducing the amount of crystal violet, the rate of the reaction is going to decrease. And so if you had if you waited like 2 minutes before you put the crystal violet and the hydroxide into the spectrophotometer, that would have caused your change in concentration, what you actually measure, that rate would have been much less than what was actually happening. So making sure that you immediately put the reacting crystal violet and hydroxide into the spectrophotometer to be measured was extremely important.